I made it.
You made it. We are so glad. We are so lucky. Happy to have you here.
Happy to be here.
Welcome, Kelsey. How's your day been so far? Was it worth coming?
It was definitely worth coming. The people, I stand out there in the hallway and I get to meet so many people. And the best part, people don't know that in between those times, you meet people that say, I read Kubernetes the hard way right before an interview, very little Kubernetes skills. I'm pretty sure that person's in the audience. And they read this documentation, they get all the skills that they need, and they land a job. And you just get that feedback when you're in person. So this work that we do, it matters. Even if it's asynchronous, when we say we're self-taught, we're really just being educated by the teachers we've never met. And so when I show up to places like this, I get to meet all those people. So it's definitely been worth it so far. So hopefully this session meets the criteria.
Nice, thank you. So yeah, to meet these criteria, we have gathered some questions from the community. Everyone has promised us that they didn't use ChatGPT at all. So let's see. And the first question for you would be, you have been part of this cloud-native ecosystem from almost the very beginning. You have even shaped it a little bit, or a lot. It has grown to quite a lot of complexity, right? There are a lot of moving parts, a lot of different technologies to overlook. What do you recommend to companies? How can they overlook all of this complexity and still leverage the cloud-native technologies to their fullest?
I mean, the truth is there's no new complexity, right? You had the same problem before Kubernetes started. Instead, you solved it with bash scripts, Linux, systemd, Unifile, Splunk, right? You had all of these scripts, all of these moving parts. You know, there's 20 years of legacy for some of these companies, 40 years of legacies of all these companies. So the problem was always there. Kubernetes didn't create microservices. Kubernetes didn't create distributed systems. It was just another tool to express how to deal with them. That's it. So for most companies, Kubernetes is not a look forward to the future. Kubernetes is a checkpoint on the previous 10 years. When you saw Kubernetes for the first time, that's how we were doing things 10 years ago. We just formalized it. And I think for most companies that are struggling with this, you have to realize that the complexity was already here. You don't need a Kubernetes strategy. You don't need a container strategy. You need to understand that there's complexity and understand how you currently deal with it. Let me be very clear. Most companies still don't know how many apps they're actually running. Right? If you say, how many apps are in your data center? They have no idea. But Kubernetes is complex. The complexity is already there. So I think most people would just take a step back, do a moment of reflection, and figure out what your current total complexity is. And then you ask, does Kubernetes actually help? That's it. And in 10 years from now, 20 years from now, we will be here talking about something entirely different. And someone's going to ask the exact same question. How do you deal with the complexity? And the answer will be fundamentally the same. Look at what you have. Do you understand it? If so, it will be easy for you to make a decision if the new tool helps or not.
Thanks. Maybe that's also a good segue into the next question, actually, because when we were talking about what we're going to talk about next, we talked about it a bit yesterday evening. Serverless is one of the big next things in computing, or at least that's what some people say. And we've even had talks about it today. How do you see that fit into the cloud-native ecosystem, or will it even replace it? Will we have to adapt? Or
I remember all the AWS Lambda people. Some of y'all are still here with your little Lambda tattoos. They're on Twitter like, Kelsey, Kubernetes is the old way. Everything will be serverless. And some of y'all may have been there. I don't know if you remember KubeCon 2017. I had a talk called Path to Serverless. I'm looking like, wow, I'm already outdated. I thought we were the new thing. Just a few years in, the serverless people was like, nope, we're changing the game. So I had to find out for myself. So I'm working at Google Cloud. I decided to go work on cloud functions. And I decided to join the team that was working on Go support for cloud functions. And I was given a talk at GopherCon in about 6 months. And so I said, hey, I want to go learn this from the very lowest levels. How does Google Cloud Functions actually work? So I started doing a small set of contributions internally. And I started looking at the design. I'm like, wow, it still runs on servers. We're still sending logs. You still need CPU. I was like, maybe if I write some code, I will feel the magic because these people seem to be very excited about the future. So I'm writing my function, hello world. I was like, oh, this is kind of nice, right? You have this little function, hello world. I was like, this is nice. And then I said, let's connect to a database. And there's no function main. Where do you import the database driver? And by the time I was done writing a real application that does something, it was the same amount of code. Instead of function main, it was this random signature, start. I was like, what am I going to do with this? And I was doing all of these weird workarounds for cold start, for logging and metrics. And they were telling me you have to think differently, so you got to change your mentality. I was like, let me guess how serverless works. Data comes in, okay, he seems to understand. You process the data, how does he know? And you return a response. They're like, yes. I was like, it's the same thing. And so after shipping Cloud Functions, the Google team started working on Knative and a thing that would eventually be called Cloud Run. And one thing people like me were very adamant about, Cloud Functions and Lambda is a framework, no different than Express, Ruby on Rails. It gives you a contract. This function signature, this type, and there's some semantics. You will pay per use, whatever you want to make of it. But I remember going on Twitter to those same people, after doing this with my hands, after sharing in the implementation, I even gave a few talks at serverless events. I say, I guess that one day you will realize putting code in a zip file and copying it to a server doesn't make any sense. Kelsey, you have to change the way you think. Let me guess. You're taking Ruby. You put it on the file system, and you're starting it up. How does he know? Because it's the same thing. And I said, I predict that one day Lambda will support Docker images. And I had all these fights with people that had a hard time understanding the difference between Docker runtime and a Docker image. And 2 years later, at reInvent, Amazon on stage said, Lambda now supports Docker images. I took the day off of work. I logged on Twitter, and I just did a victory lap. All the serverless people, welcome to the world of Docker. We have tutorials. This is a safe place. You can version your code. You have registry. You can scan. You can run it on your laptop. And then I think they also realized that it's the same thing. And the thing that I like the most about where serverless has eventually ended up is the philosophy. How can you define a contract between compute and what people want to use? You can apply it to databases. You can apply it to functions. You can apply it to containers. And we've seen this before. Some people used to call it PaaS. Some people say it's all about the billing model. Some people think that scale to zero is a big component. On Cloud Run, we decided to make scale to zero optional. You have a flag where you can say always on. Why? Because you want to send logs after the request. You can't do that if the CPU is throttled. And once we really realized it, it's more like let's people decide the operational model that they want. If you want to pay per request, you can do that. But if you want to run something like HashiCorp Vault on serverless, why couldn't you do that? And before I left Google, one thing that we noticed is that when you started to write more traditional style applications inside of these serverless platforms, you were doing things like, if you ever deployed into like even Amazon, you had this thing like the VPC connector, where you have to create something that gives you network access to your VPC, where the database is, and you're doing all of this workaround. And eventually, we decided that we would just move serverless to run on exactly the same VMs that Kubernetes runs on, that VMs run on. So that way, there was no difference other than what framework you wanted to use. So my vision around serverless is it's a great target to aim for the end user, give them an experience that maps to what they actually want to do, no problem. But let's not pretend that it's not just compute that's being delivered under another abstraction. And it's been about 10 years now, and the world didn't change. People are still writing apps, and most of those serverless people are like, can you teach me Kubernetes? So welcome.
So you just tell them you just need to think differently.
Yeah, and then you remind those people that mainframes are still here, VMware is still here. All of these things tend not to go away just because a new abstraction came out. And so I think it just helps to just remain humble and pragmatic and just use the tool you need.
So if we generalize this to cloud-native architectures, what are some common misconceptions that you often encounter?
So the first thing is, I worked at a cloud provider. Do you know what cloud native eventually became? Whatever you're willing to pay for. Right? How do you want to pay for this switch? Now we don't want switch, it's legacy. It's cloud native. Ooh, let me see. And so what it ended up being is whatever you wanted to do in the cloud. So then let's step back from a moment. There's no cloud native because most of these technologies actually run well on-prem. You have things like Prometheus that were designed to work well on a laptop or work well inside of a Kubernetes cluster. I think we just agreed on some cloud-like philosophies. Your app should be decoupled from a machine. That to me, if you take one thing about the understanding of cloud native away, that's probably the number one. If your app is decoupled from the machine, meaning you're not writing Solaris apps, you're not writing apps that have a bunch of dynamic dependencies that only work on Red Hat 7.2.1. If you decouple from that, then you get just enough portability that I can probably run in Cloud Run. I can run on VM, Amazon, Azure. And if you're using the right language, like maybe a JVM-based language, a Go-based language, then you can target different architecture types. So the same app that runs on Intel, you're one compile flag away from ARM64. That's cloud native, that you have this ability to be separate from the infrastructure. And then you pick your stack. You want Cloud Run, use it. You want ECS, use it. That's the cloud experience. And then the underlying infrastructure, however you want to deliver that. And I think once we all got to that point, then it feels like you have a choice. I think before, people were really tied to their current stack. And so the cloud felt like a distant place. But once you start to be able to do the same things in the cloud on-prem, if you buy NetApp, you can get an S3 interface on NetApp. Is the experience so different between cloud and what you have on-prem? And as that goes away, that term starts not to make a lot of sense. So I just think it's a paradigm loosely based on this concept of separating the app from the infrastructure, then you have choice.
I guess many of us know the 12-factor principles there. I guess that goes a bit into that direction, right? If you follow, the more you follow those, the more you can decouple your app from whatever it runs on.
Yeah, I mean, I think 12-factor was cool until you had state. And it turns out Cloud Foundry was cool until you had state. And I think for most people, Kubernetes was the first time in these newer systems that we realized state is going nowhere. Every binary is stateless, so this idea that my app is stateful or stateless doesn't make any sense. If you download a database binary, there is no data in it. You do not recompile the binary with your tables in it. Right? So the state is always decoupled. It's really about where does the state live. And I think when Kubernetes came out, it finally gave you a way to take 12-factor principles and add the missing factor, which is your actual state, and then describe that too. So volumes and config maps and secrets. Most people never got really far with key value pairs and environment variables. Sometimes you really do need 10,000 lines of XML to be your config. All my Java Hibernate programmers out here. And that reality was matched by these new tools. So Cloud Native wasn't about only 12-factor. I think Cloud Native represented all the things you can do with at least an API to express your intent. And that was the game changer.
We have also some new terms emerging, like platform engineering. Does that also help to like distinguish between the application and developing the application and separating it from the infrastructure it is running on?
You know what's nice about these buzzwords? They sell stuff. Right? You ever have a sales rep that moved from one company to a new company? You say, hey, I sold you VMware, now I want to sell you OpenShift. We're doing platform engineering. What is the difference? What is literally the difference? I'm watching people saying, now I'm doing platform engineering. But it's like, yesterday you were doing DevOps, but today we're doing platform engineering. And I was like, could you prove it to me? And they logged in LinkedIn, they say, you see, platform engineering. This is the only criteria. But I think for people that have always understood what the job was, if someone is using VMware As a platform engineer, your goal is to make VMware usable for the purpose. So if you're a developer, do you care about VMware? Hopefully not. You wrote an app, you need to bind to some port, you're going to receive data, you're going to process the data, and you're going to return a response. You might need some libraries, libc, libxml if that's your thing. And so when the team shows you VMware, it's like, what do you want me to do with VMware? Run this app. And for 40 years, we've been trying to figure out how to take an app and put it on a server. It doesn't make any sense. Think about it. Can you run this app? You've been running this app for 40 years. Yeah, but we have to do DevOps. To copy this app to the server with the correct config, it's really challenging. So if I'm a developer, I'm looking at you and be like, for 40 years, you've been trying to figure this out. So if I did it manually, how would it work? I build the app. I SCP it to the server. I put the config. I start the app. And I send it traffic. He's like, you make it sound so easy. And so we get all these tools and we cause all of this confusion. It's the same fundamental principle. If you've used Lambda, how does it work? You take the app, you put it in a zip file, you go to the form, you upload the zip file, and then it runs. What is fundamentally different? So I think when we hear platform engineering, if you put the buzzwords to the side, what is the job? I take the platform that we bought and we try to make it usable for its intended purposes. So if you're 15 years ago, you get VMware, you can Pixie boot it, automate it with Red Hat Kickstart, put Puppet on it, get the config in place, lock it down, put the JVM, get the class path right, and then the developer can just copy a WAR file into a directory. It will auto-deploy over and over again. Automatically, you could have done that 15 years ago. Okay, you missed that one. Docker came out, same thing. You put the Docker daemon on the server, you build a container image instead of an RPM, and then you could have told the Docker daemon to run the code automatically, exact same process. But now Kubernetes is here. Let me guess what you're going to do. It's the same thing. So to me, platform engineering is about filling in that gray area between what it does and what we need to do, and whatever the means necessary. And when a better platform shows up and there's less things to do, then great. Just do that little bit of glue code between the two and you'll be fine. And there will be no one platform to rule them all. This is where we get stuck. Everything will run in Mesos. Everything will run in Kubernetes. Everything will run in Cloud Foundry. Everything will run in Lambda. And then before you know it, the development team is like, now my code is running in all 5, and then you quit. So that's the way I think about platform engineering. It's just a job that's not necessarily tied to one way of doing things. It's a responsibility. If you're a developer, you will learn how to deal with mobile when the time comes. You will learn how to deal with the web when the time comes. So I don't really think about the buzzwords. I just think about being a professional and doing what's necessary for the intended purpose.
So, I mean, buzzwords are showing up constantly. New technology is emerging as well. So, how do you use whether, in general, how do you evaluate technology and you know it is the right technology to solve a specific problem?
Y'all be surprised that there's almost no new technologies. Just try it. When Service Mesh came out, some people went to the tattoo parlor and was like, can you do the sailboat and Istio? how you spell it? And then when I saw Istio for the first time, the first thing I did was say, okay, what do I understand about networking? And so people's like, you can do TLS with Istio. Oh, great. How would I do TLS with Nginx? You can do TLS mutual auth with Nginx 10, 15 years ago. So to remind myself, I would just set up 2 machines and take Nginx and create SSL certificates and have 2 things talk by using Nginx as a proxy, just to make sure I understand the fundamentals, what we could do a decade ago. So now let's test if this is really new technology. They called this service mesh, but that's a distraction. So I asked someone very simply, actually I asked Matt Klein, who created Istio and Envoy, or Envoy in particular, and I just go to the office. This is my Nginx setup. Show me what Envoy brings to the table. He's like, Kelsey, you'll be surprised. It's roughly the same thing. It's still HTTP. We still have to adhere to what the kernel allows. We're still moving data back and forth. I'll let you in on a little secret. It's the same SSL search as before. And so then I just find the difference. The difference is in Envoy, you can actually program the proxy using config. And that config can then be used from a control plane. For some people, that is a new way of thinking about using proxies at scale. So instead of Puppet creating Nginx configs and restarting a bunch of load balancers, maybe use a control plane instead. So when I hear Istio, I see the diff between Envoy and Nginx and this control plane pattern. So now I'm not looking for new technology. I'm thinking about, a different way of doing the same thing. It's still HTTP. It's still URLs. It's still endpoints. Auth in and auth z is exactly the same. So it doesn't take me a year to understand Istio. It takes me a couple of weeks to understand Istio. And I encourage everyone to take the same approach. We're not changing CPU architectures here. We're not changing programming paradigms here. We're just changing the way we leverage those fundamentals.
So when you're saying there are very few things that fundamentally change how we actually do software and how we work, I mean, all of us love shiny new technologies, right? So do you see any disrupting major big changes that are coming up in our near future? I mean, we already talked about serverless, which is obviously one of those. But
I've just been around too long that every time someone says it's going to change everything, it doesn't. Have you really seen something change everything? I have not yet seen anything change everything. It's usually an iterative process. And for some people, they just come on that iterative curve a little later than others, so it looks like a lot has changed. Some people only know COBOL and mainframe. And they look up 25 years later, it's like, oh my God, internet. So for them, it looks like this huge jump. But if they were paying attention every year, it wouldn't seem so massive. Right? So when I see AI is generating code, I was like, I've seen a lot of people generate code using various means. Protocol buffers will generate code. So I can't be as impressed by watching ChatGPT generate code. It's still cool, don't get me wrong, but the fundamental is roughly the same. There's an input that generates code. Is the code correct or not? We're still back to that. But you understand, so I'm a more pragmatist on it. Mm-hmm. So I think the big wake-up call is when you see people that really understand how to work well together. That's the disruption. When you see a small team that just kind of clicks together, they understand these things, they're reasonable people, they're not just doing Agile because they read about it, they're not debating waterfall between Agile. These are silly concepts and waste of time. They just actually learn how to get things done, and they do it. And so what most companies are looking for is how do they do that? How do they fight internal politics? There's managers that can just veto good ideas because they don't understand them. So they're looking for innovation, but that's the core problem. And no one has that for sale. There's nothing where I can come in and change your company culture. Some people thought they could buy Cloud Foundry, open a little bit of it, and just rub it on the teams. It doesn't work. Right? So that's why when I think about innovation and all of these things, it's more about execution. So I love it when people take some of these new tools as a motivation for execution. Right? We have not been thinking about metrics. We haven't figured out how to do it. Prometheus comes out. We finally have a checkpoint on how some people have done it, and we're finally going to finish it this time. And it's only when they finish actually adopting Prometheus deeply within all the apps, they finally have dashboards now, they finally have alerts, they're starting to be able to do an analysis. That's when it feels like innovation. But the truth is, everybody can download Prometheus and try it.
And do you have any, any technologies or paradigms there that currently excite you, that you see emerging?
No, if you would just get to, think about it. If you can get to 2016, state of the art, 2016, right? If you can get to where we were 8 years ago in terms of available technology, your company will look amazing. If you can get to 28 level of technology, you'll be just as efficient as Google and Facebook. You would be in position to invent React. You would be in position to invent Llama if you had 2008 technology. Think about it. You would be as big as those giants. You would be in position to create Kubernetes if you had 2008 technology. So people are looking to the future for this thing that's just if you can finish something. So maybe we should start a new movement called Finish. Finish ops. If you start it, you finish it. That's the difference between all these legendary companies and movements, people finishing things. The difference is you go there, some of you work at vendors, I won't ask you to raise your hand, but you know how this works. You go there and they have a POC for everything. We have OpenShift, Cloud Foundry, we have that too. We have Deus, like they don't even have Deus anymore, but we're still doing POC. They're out of business, the project is deprecated. Oh, we'll tell the team. But this is the state people are in. They're in these perpetual POCs because they don't have roadmaps for this technology. So the thing that I think works really well, really nicely, is when a team looks at their current stack, calls it V1, whether they like it or not. Just be honest about it. And then they just draw time. And you ask yourself, what do we need? What does my company specifically need? We need TLS mutual auth. Great. There are many ways of achieving this. And you just put a dot on the timeline. So by next year, we will have TLS mutual auth and we will finish it. That way, if you visit that same company 5 years from now, they should not be talking about metrics and DevOps and these basic things that can actually get done if you're just willing to pick something and finish it. So I'm so much of a pragmatist because I help create a lot of these new things, and I watch some of those new things not pan out over time, and I step back and realize that it wasn't the new thing that makes the difference. Some people are like, God damn it, Kelsey, I wanted something to put on LinkedIn. Finish something and put that on LinkedIn. Talk about what you actually finished. Your resume will look so much better if you can describe the impact of the thing you finished. Most people's resumes look like all the things they started. Downloaded Prometheus. Did you do anything with it? No, I don't think we used it, actually. But I am certified.
So we thought of opening this up to you. We have a cube, a microphone that can be thrown into anyone who has a question.
Q&A from the audience. This is the most memorable part of any fireside chat, both for the speaker and typically for the audience, because I'm always curious about what you actually care about the most. So this is your opportunity to do that. Any question is fair game. If it's a terrible question, I will pretend I didn't hear it and we will just move on to the next person. So if you want, raise your hand and we will throw the cube to you.
If you wouldn't work in software engineering, if you could choose any other job or work or project you would do, but not computers, what would you do?
Man, you know, the thing that's magical about tech, and I was telling people we were talking in the fireside chat, it's like this puzzle that you get to solve. And even though most puzzles that you buy, there's a nice piece of art that you're assembling. It's like your guide about the North Star, why you're putting the pieces together. But for me, just the act of solving the puzzle that I will never frame. Sometimes I just break the puzzle back and put it in the box. But just this idea that I can actually make something come to life. I can finish something, put the pieces together and make it work. But the part that I loved the most about tech was the part where you really, really help someone. Like seriously, it sounds cliche, but a lot of people are doing this work because they need the money. They're doing this work because they want a job that has dignity and respect. They need to take care of their family. Their child may have health problems. And then someone comes along and says, hey, Kelsey, I watched the video, or I used one of your libraries, and I got it done, and I got a promotion because of that. That is very, very powerful to be able to have some influence on another human being's life. And then what does that lead to? You inspire these people to go do amazing things. So when I think about all the professions, money aside, imagine being that teacher that inspires someone to want to go be one of these things, right? A lot of great teachers in the world have the exact same impact over people in their lives. So a lot of the work I have been doing has been education. All of these prototypes and libraries, we learn something and we take what we've learned and we turn them into libraries that the next developer can import and hopefully saves them time or learns how to do it. And so this very active teaching, right? The early days of Kubernetes, the most enjoyable parts wasn't hacking at night, trying to figure out how to make CNI work with this newfound stack that we had. It was the thing when we finished that part, and then we went to the meetups, and we showed the whole world how to do it too. And then we will come to conferences like this, and the thing you've worked on, they're now teaching the rest of the people. And even more importantly, those people will take those projects to levels you've never imagined yourself. That is such a powerful thing. So if I can only do one thing differently, it will be something like that where people remember that impact. You get to be part of their journey.
Thank you.
Any more questions? Show of hands.
All right, stand up if you have a question, and then we'll throw it to you. All right, you can do it. You got this. Computers are hard, but so is this. You got it.
You talked about organizational culture as one of the hardest things to change. Have you ever managed that? Like, did you go somewhere and you like changed the culture in a good way?
Yeah, but you know, the question I always ask, was the cost worth it? Seriously. So I remember when I started my career, I was very afraid to even apply for a job. So I opened a small computer shop and did IT services and contractor work because I found it easier at the age of 18 to just lease a small office, buy computer parts, because there was no criteria, no college degree requirements, no 50 years of Solaris, 200 years of AIX. It's impossible to meet those standards. So I was too intimidated to even try. And I carved my own way. But then I started getting, at some point I spun that down and started working in normal corporate America. And I remember every 6 months to 2 years, maybe even 1 year, I would just switch jobs, learn everything I could and move on for more money. Learn everything I could and move on for more money. And one day I went to go work for a financial institution. This is the kind of place you have to wear a shirt and tie. On Friday, they let you wear jeans. I'm like, I cannot wait till Friday. And so I'm working at this company, and I worked in web hosting. I worked in Google Data Center before, voice over IP. I worked in small companies that had missions and just get things done. And I always thought these people that were making double the salary than me had to be amazing. It's like, how do you get paid double and not be amazing at your job? So I put on the shirt and tie thinking that this is what was required to be at that level. And you get there. And I was like, show me how you do deployments. And I remember the first time someone showed me SharePoint, I was like, what does this have to do with anything? And they said, we have this thing called Runbook. And I'm sitting there like, oh my God, you have a Runbook? What do you do with it? He says, I'm going to show you. You have to be very careful. Read all of the steps, copy and paste. I'm like, what? How many times have you done this? I don't know, at least 1,000 times. And you still come back to the Runbook. He's like, yes, we're going to get your Jira logged in set up. I was like, what is Jira for? Well, you have to wait for the ticket, and then you can use the Runbook. And so you're just sitting there, and I'm thinking, this is what the pros do, so let me be patient and learn. Can I loosen my tie? Sure, you don't need it up here. So you go to the Runbook, and I remember learning everything, and I'm telling my wife, they do things like the professional way. They have this thing called Jira and SharePoint. You have to log in for 1 hour, but once you're in, you can do stuff. And I watched them, they SSH to the server, and they were running the commands, one by one. I was like, I guess this is what the pros do. And so when I was able to do it, I was like, I'm finally professional. I was doing it the wrong way the whole time. Think about this. So it's like November, so this is close to the US holidays. And I don't have vacation time, and everyone else is on vacation. And we're writing a new payments platform. Everything is running on mainframe, Cobalt. They make a lot of money this way, IBM MQ series, etc. And now they're doing things with Java, JBoss. Everybody's excited about the new platform. So every day, 10, 20, 30 Jira tickets, the team will get the ticket, Runbook, copy the commands over and over again. And so now I'm by myself. And so I'm looking at this like, well, nobody's looking. So I'm going to like write a script. I think it's okay. And I remember I wrote this little tool that would go to Jira, and I created some custom fields, and I go to the development team on the 3rd floor. Hey, if you just put we were using CVS, so before Git and before Subversion, You just say, if you put the CVS tag in this box and you hit save, I will grab the tag, get the software, and just deploy. And so they started opening Jira tickets this way. And every time the Jira ticket get opened and approved, I had a little cron job that would just scrape Jira, get the tag, and do the deployment. So every second done, they were like, hey, what are you doing down here? I was like, I just have the script. And the dev team was like, this is amazing, this is great. 1 week goes by, I'm just chilling like, I love this job. It's too easy. They're not even asking me to do anything else. And then the team came back. And then they were opening Jira tickets. And they were doing things using the build guide. And things were taking long. You know, developers get used to a certain pace. And then they came back and say, hey, we're going to lunch. I will get to this ticket when we get back from lunch. Then the developers come downstairs and say, hey, Kelsey, can you just do it, please? It's like, what are you doing? I said, well, I have a script that looks at the custom fields. And they're like, hey, that's not compliant. So in enterprise, if you don't want something to work, you can just say, I don't know if it's compliant. And no one can prove it. So then you have to stop. And literally they say you have to turn it off. So we turn it off, and I'm sitting here like, are you serious? And so eventually the pain got so bad that the VP of engineering was like, hey, whatever Kelsey was doing before is the only way we're going to get to the deadline to get this new payments platform on time. We will lose money. And now I'm observing how this actually works. What politics plays a role in this. It's not enough to be a good engineer. Not at all. You have to have political connections with enough people who can convince the unwilling. And so he demanded it be put back. And the thing that was weird to me is that the team almost just said, well, you manage it by yourself then. That's your idea. That's your process. Good luck. So if something would break, they said, we told you. We should go back to SharePoint. So we're not going back to SharePoint, man. Just fix the script. So you fix the script. And then I remember we had another set of tasks, and I just had this formula, but I made one correction. What you have to do is start giving credit to other people. You have to go get the person that's doing it the old way, and you talk to them and say, hey, would you like to try something different? And they're like, not really. I'm retiring in 2 years. Like, I'm going to do this for 2, and I'm out. I was like, no, I'm going to show you something. But first, I need you to teach me what you currently do out of respect to make sure I'm not missing something. And then they take the time to teach me how to do it. I go back to my desk. I learn how to do it. And I do some automation. I say, hey, look, I got this automation. But can you verify that it works? And they verify. I was like, yeah, I think it works. How do you run it? Show them how to run it. And they give me the stamp of approval. Then I send an email with both of our names. Me and this other person, we created this. It now automates this very painful thing. And the email goes out, and they're looking like, I did not know. That looks like getting things done. I don't do that. But then they see the email that comes back. This is amazing. This is great. And they're like, oh, yeah, I was a part of that. So now they're feeling good. And it becomes contagious. Everybody wants to feel this way. And so you give everybody a taste of success. You give everybody a taste of success. And then over time, I remember I was at that company for 3 years. I learned to go from just being a great engineer to being very strategic. And a lot of times I had to wait. So sometimes you have a working solution, they will tell you no. Sometimes for good reasons, and I would address them. But I remember I waited almost 6 months for one solution. We had a new web server. It was being overloaded, the old one. I said, let me switch to Nginx. And I promised my career that it will work. And every change window, no. Change window starts at midnight. It stops at 6 a.m. And I said, if you let me do it this time, I promise it will work. And eventually, they allowed me to try it. And it worked. And when I got that credibility, I used it to be more ambitious for the next project. So it's almost this give and take. I have to do something that they need, not what I want first, no matter how innovative I think it is. And when I built that much currency, I was able to get things done. So much so, I remember at that very same company, I gave my very first public talk at PuppetConf in 2012. Because I did all of this innovation on all the things I learned at that company. And so I came back 5 years later to just talk on site. and they were already using Kubernetes in production. They understood etcd, and this is before it got super popular. And that's how I actually knew that I changed the company, that I could leave. And the ability to get things done and try new ways stuck around. And so, yes, I've done it before. So that's why when I meet people and they tell me it's not possible, I've learned COBOL so I can write it in Python. And sometimes you got to stop complaining and just be the one to step up and demonstrate how it's done. So the answer is yes. I know it's a long-ass answer. But I had to give you context. It's totally possible.
It was very interesting. Thank you. Next.
We have time for one last very brief question, or a very brief answer.
Yeah, it's not going to be a brief answer.
So as you may know, Switzerland is now trying, or it will be the law that software goes open source whenever it's made by public institutions. I guess you even tweet about that.
I did. Very impressive.
And I'm wondering, why is it not a common practice around the world? Are we afraid that open source is killing jobs? Are we afraid of security? What's your take on that?
The thing about open source, which I love, and I've done a lot of contributions, but when people say they dislike Oracle because it's too expensive or it's too complex, if you've ever worked at a vendor before, the reason why Oracle gets complex is because the customer says, I want column level locking. Okay, no one else is doing that. It's going to be expensive, but we will figure it out, and you have to pay for it. And eventually the customers ask for so much and they want it now. In the world of open source, you have to get consensus first. We can't just go change Kubernetes and make it do something without getting approval from the community. And sometimes consensus is too slow for actual innovation. And so when you think about open source, in many ways, it is no competition for the speed of someone willing to do something right now for money. And so you end up with these other standards. And typically open source has shown, even from its origins, it's really good at replicating things that exist to democratize said technology. It's really good at taking ideas that have been proven to some degree and making a form where everyone can contribute to those ideas. In my opinion, only recently is open source pushing the bar on something that's net new. And if you've ever tried to use a net new project as a large, complex government or enterprise, who do you hold accountable for getting the feature that you want? It's a really weird thing where you say, we would like this very important feature. Yeah, there is no one that's going to do that for us. Who can we pay money to about that? We were to make a GitHub issue and get in line. Maybe your team can do it. So I think now open source is going to have to figure out, can it provide the same SLA and accountability for how it's used? Remember, Red Hat did a lot for Linux to give people that difference between pure open source and a corporate entity behind it to do those things. So I love the effort, but now I want to see companies or countries like the Swiss decide that they will actually pay open source developers to work on this full time, even on things that may or may not net benefit the country. So we'll see if this is going to pan out. So ask me in 10 years how it's going. All right, I know we're at the end of this. My whole goal was to be pragmatic. I love these technologies as much as you do, but I don't want you to get overwhelmed and confused that the technology is more important than your team or your ability to actually execute. And for most people that have found the ability to execute, they could do most of the things we've been talking about with just a bunch of VMs. They can do it with bare metal, or they can do it with Kubernetes. So celebrate the tools, but don't do that over the actual team you work on. And I think you'll get all the things that you've been after. Thank you for hanging out with me.
There's one more thing.
Oh, you
So
still have it.
we were teasing. Here it is.
These are the same ones. Are they expired?
Actually, they're not. Thank you very much.
Awesome. Thanks for having me.
Thanks, Kelsey.